Hello, I'm Professor Rad, and today we're going to talk about our order of operations. So we've discussed a whole plethora of ways that we can combine numbers. So we can add, subtract, multiply, divide, we can use exponents or radicals. So today we're going to examine what happens if we have more than one operation going on at once. So it turns out that there's like a hierarchy of operations. Some operations are like more powerful or more important, so they get completed first, and then kind of goes down the line with like the weakest operations at the end. That's how I think of it. I think of it as like strong or powerful operations and then like weak or low level operations. So definition 11 is the agreed upon order of operations. So it says if you have more than one operation to complete, here's how you do them. First, if you have any grouping symbols, and we'll talk about what that means in a minute, but if you have any grouping symbols, you're going to do the operation inside those grouping symbols first. After that's complete, you're going to go ahead and complete any exponential or radical expressions. Then you're going to multiply or divide, and you go from left to right here. And lastly, you're going to add or subtract, again, from left to right. So when I talk about the power of operations, I'd say the most powerful operations are exponents and radicals. And exponents and radicals undo each other, so they're on the same level. Same thing with multiplying and dividing. Those guys are a little bit less powerful than exponents and radicals, but they're on the same level, multiplying and dividing, once again, because they undo each other. And then lastly, the weakest operation is addition and subtraction. So generally the order or the powerfulness goes exponents and radicals, multiply and divide, add and subtract. But sometimes you might want to do a weaker operation before a more powerful one. So sometimes you might need to do some addition or subtraction before you do multiplication or division. So to do that, that's why we have grouping symbols. So grouping symbols are like, hey, do this weaker operation first and then carry on. So some people use lots of different ways to remember this order of operations. So you might have heard, please excuse my dear Aunt Sally, or PEMDAS. Some folks know BEDMAS, but my favorite is GEMS. And here's why. So in PEMDAS, or please excuse my dear Aunt Sally, the P stands for parentheses, E for exponents, M to multiply, D to divide, A for add, and S for subtract. Similarly, in BEDMAS, B stands for brackets because brackets can also be used to group operations, E for exponents, D for divide, M for multiply, A for add, S for subtract. So the problem that I have with these two is that because of how you remember them, it sounds like you do multiplying before dividing in PEMDAS or adding before subtracting, for example. And that's not always true. If you have division happening to the left of multiplication, then you need to do that dividing first. You work left to right. So that's why I like GEMS a little bit better, because G stands for grouping symbols, and as we'll see in a minute, there's more than just parentheses or brackets that can be used to group things. So I like G for grouping better, E for exponents, and then simply M, because M is multiplying and dividing. So M is a stand-in for both of those things, so we remember to go left to right. And then S is a stand-in for subtracting and adding, once again, so we remember to go left to right if we have both. So, before we dig into a few examples of these, I have a couple of notes for us. And these are things we have to be mindful of as we go through to do multiple operations. So the first thing is that, oh boy, multiplication. The notation for multiplication is like crazy. So very basic symbol that we've been using for the most part is the cross symbol, but then something happened. Then algebra got invented and X was used an awful lot. And so if you're using x to represent a variable, you don't want to confuse that with the cross. So another notation that can be used is the dot notation. But if you're writing this by hand and working very quickly, you might accidentally write 4.8 or interpret that as 4.8 instead of 4 times 8. So the symbol for multiplication, some people use cross, some people use dot, and some people use parentheses. This is another reason why I don't quite like PEMDAS, because in this case, these parentheses are not being used as grouping, they're being used as multiplication symbols. All 5 of these notations mean the same thing. They mean to multiply 4 and 8. So you can do that by putting a number right in front of parentheses with nothing between, and just the number inside the parentheses. Or you could put just a number on the outside to the right of the parentheses instead of to the left. Or you could put both numbers in parentheses. In our next unit, we're going to talk about negative numbers, and the parentheses work nicely for negatives to help us differentiate between a negative sign and a subtraction symbol. So I think that's why parentheses became popular. But just know I'm going to use all of these different ways of writing multiplication. So you just have to be careful. Is the parentheses being used for multiplying, or is it being used for grouping, or is it being used for both? In note 15, here's our notation for grouping symbols. So here we see our typical parentheses that are being used. And notice that there's nothing in between the 3 and this parentheses. So this phrase or this notation here means the same thing as if I were to write 3 times and then in parentheses 12 plus 15. So in the original way that this is written, those parentheses are doing double duty. First, they are grouping this addition. And then secondly, they're saying there's also multiplication in there as well. But let's check out some of the other ways that grouping can be implied without using parentheses. So let's look at this expression here. In this expression, notice that the 12 and the 15 are kind of grouped together above this bar or above this line, and the 3 is underneath. Another way of writing this expression would be to have in parentheses 12 plus 15. So we're grouping that together. And then this bar is another way of writing division. So 12 plus 15 on top divided by 3 can also be written in this way. Expressions like this are really common in a statistics class. For example, you have to find a thing called a z-score or a mid-range, and those formulas look kind of similar to this shape. This next one has implied grouping up in the land of the exponents. So notice that both the 12 and the 15 are small and they're both raised. So another way to think about this one, and since I'm running out of room, I'm going to move down a little. Another way to think about this expression would be 3 and then having parentheses around those exponents there. So sometimes you see grouping not using parentheses, but based off of the level. Here we're using the radical to group. Notice that this radical extends over the entire top. So that's saying both the 12 and the 15, that addition is being grouped together underneath this whole radical. And lastly, here we have brackets being used. They're basically the same thing as parentheses, just a different form of writing it. Often what happens is these square brackets will get used if you have other grouping going on. So if you have one group and then another group, one group might use parentheses and then the other group might use brackets to help you differentiate between them. So I've got a few examples for us to work through following this order of operations. And I'm going to take this GEMS along with me to help remember this order. Okay, so if you're following along for my class and you're using our book, I've decided to record the videos in a slightly different order. So I'm going to skip ahead to example 35, and then we'll cycle back and come back to some earlier examples later. So what I'm going to do is I'm going to follow my order of operations using GEMS as my mnemonic to figure out each of these expressions. And I've got 6 of them here. And we'll go through them one at a time. So the first one I've got is 36 divided by 4 times 3. So what I usually do is I look to see, do I have anything that's grouped together? In this case, I don't. So I'm just going to move down to the next level, which are exponents. I again don't have any exponents happening, so I'm going to move down to the next level. And the next level is for multiplication and division. And that's all that I have here. I've got some dividing and multiplying. So I'm on this level. This level says we're going to multiply and divide going from left to right. So I'm going to do this division first. So we're going to start out by ignoring this times 3. We'll just hide it. We'll say, what is 36 divided by 4? So 36 divided by 4 is 9. So I'm going to put my 9 here. And then I'll bring down this times 3. Now there's only one operation left, so I can complete that. And so we get 27. So 36 divided by 4 times 3 is going to give me 27. Let's look at another example. Oh, it was hiding. So for this example, we once again have 36 divided by 4 times 3. But notice this time we've got some grouping symbols. We have parentheses around the 4 times 3. So that means we're going to do that expression first because of the grouping symbols. So I'm going to do 4 times 3 first, which is 12. And then I bring down the 36 divided by. Now I'm going to divide 36 by 12. And I happen to know that that's going to give us 3. So let's move my note for a moment here, and we can check out these 2 questions. So notice these 2 questions are identical, except we've got grouping symbols around the 4 and the 3 here. So we had 36 divided by 4 times 3, 36 divided by 4 times 3. And we can see that the order of operations is important because when we did the dividing first and then the multiplying, we got 27. But when we did the multiplying first and then the dividing, we got 3. So it makes a difference, the order in which you do your operations. Let's go ahead and work on a couple more together. So for example C, I have 28 minus 17 plus 6. So again, I'm going to follow down my list. I don't have any grouping symbols and I don't have any exponents. And this time I don't have any multiplying or dividing either. All I have is subtraction and addition. So we're going to subtract and add going from left to right. So I have to do 28 minus 17. Which I think is going to give me 11, and bring down my plus 6. Then I can add those 2 numbers together, 11 plus 6, and that's going to give me 17. Example D looks pretty similar, but this time I threw some grouping symbols in again. Here we have 28 minus 17 plus 6. And notice we've got those parentheses around the addition. So I'm going to do the adding first. So 17 and 6, 17, 18, 19, 20, 21, 22, 23. So we get a 23 here. And I bring down my 28 minus. And now I can do that subtraction. So 28 minus 23 is going to give me 5. Okay, again, we can see that these two questions are basically the same thing. 28 minus 17 plus 6, 28 minus 17 plus 6. But again, the only thing that's different is this one's got parentheses around that addition, so that we know we need to do that first. And again, we can see we got different orders or different answers, so it matters whether we did the adding or subtracting first. I'm going to take the opportunity here before we do a couple more examples to examine how we can work through this using our calculator. So a scientific calculator is going to have some grouping symbols for you on it. So this one has parentheses buttons right here, and that's where most of your scientific calculators will have parentheses. So if I want to work through part D to check my answer using the calculator, I can go ahead and type in this whole thing as it's written using those parentheses buttons for the parentheses. So 28 minus a parentheses 17 plus 6, and then close up that parentheses. And I should get 5. Let's see. Ta-da! Let's check our other answer over here as well. So now we have the 28 minus 17 plus 6 without the parentheses. So 28 minus 17 plus 6 equals 17. So your calculator, a scientific calculator, knows the correct order of operations. But if you don't type things in correctly, then it's going to do what it tells you, what you tell it to do, not what you think you tell it to do. So you have to be careful whether to include grouping symbols or not. So I like to use my calculator when I'm done with an order of operations question to check to make sure that my final answer matches. And if it doesn't, then that means one of two things. Well, one of three things, really. One thing it could mean is that my individual step was wrong. One thing that it could mean is that I didn't follow the right order of operations. And another thing it could mean is that I typed it in to the calculator wrong. So it's a good check, but you have to be mindful of how you use it. All right, let's do 2 more questions together. And I'm going to pull the gems back over here so we can use those. In part E, we have 15 plus 4 times 3 minus 2. Ooh, a lot going on here. So first, do we have any grouping symbols? No, nothing's in parentheses or on different levels. I also don't have any exponents, but I do have some multiplication. We've got multiplying happening here. So I'm going to do that multiplying first. I know that 4 times 3 is 12. So I'll bring down the minus 2 and the 15 plus. Okay, so I've completed my multiplication and division. The only thing left here is adding and subtracting, and those are both on the same level, so I go left to right. This time the adding is coming first on the left, so that's what we're going to do first. So 15 plus 12 is going to be 27. Bring down my minus 2. And then I can subtract 27 minus 2 is 25. Now, I can point out that in our class, one of the things that I'm assessing is not only can you do individual operations, but if I'm asking you an order of operations question, I need to know that you know the order. So you might be thinking, oh man, Professor Ed, of course she knows 4 times 3, but my times tables are really tough and I don't know if I could think of that. Or, geez, she's doing this 15 plus 12 in her head and maybe I'd have to write that out vertically to figure that out. So absolutely feel free to write out what you need to write out. For our class, if you want to do each individual operation on your calculator, you can absolutely do that. But I do need to see this order being written out. So here's what that would look like. We'll do example F using our calculator in that way. Okay, so in example F, we have 15 plus 4, and then this 3 minus 2, and both of those are in parentheses. So both of those are being grouped. So we pick one set of grouping symbols to do first. So now I'm going to move my little note, I think, up here so I can bring my calculator back on screen. There we go. Okay, so this 15 and 4 is being grouped first. So I'm going to do that first. 15 plus 4, that's going to equal 19. So I know that this is 19. And since I've done everything that's in those parentheses, I'm going to get rid of those parentheses now. But because there's parentheses here, I'm going to bring that down. And remember our notation about multiplication. There's no symbol in between these sets of parentheses. So when there's nothing in between those two parentheses, it means multiplication. All right, let's do the next step. So I'm going to do 3 minus 2. So 3 minus 2 is 1. Bring down that 19 times. And now we can finish. 19 times 1, that should be 19. Yeah, we got 19. To check my answer on my calculator, I'm going to type this entire thing back in. So in parentheses, 15 plus 4, close the parentheses, open a new one, 3 minus 2, close it up, and drum roll please. Ta-da! We got 19. Cool. So when I'm working on an order of operations problem, this method is what I'm usually going to end up doing. I'm going to probably use my calculator one step at a time, but I need to know what order to do those steps in. And then I type the whole thing in at the end as a check to make sure I've got it correct. So to make sure you've got everything going on correctly here, here's a now you try problem. So evaluate each of these expressions by hand. And notice in the directions it says you can use your calculator for individual steps or to check your answers if you want. But when it says to evaluate by hand, the expectation is that you're doing it one step at a time. All right, in our next video, we're going to go backwards and do the examples I skipped, which play around a bit more with the different grouping symbols. So I hope this helped you with your order of operations, and I'm looking forward to seeing you in the next one. Bye for now, everybody.